Assume the resting metabolic rate of healthy males in complete silence is 5,710 kilojoules per day. Researchers measured the RMR of 45 healthy males who were listening to calm classical music and found their resting metabolic rate to be 5708.07 with a standard deviation of 992.05. At the alpha's 0.05 level of significance, is there evidence to conclude the mean RMR of males listening to calm classical music is different from 5,710 kilojoules per day? We can see that this is a hypothesis test about a mean, and so we want to verify that we can actually conduct the hypothesis test using students' t-distribution. And so first and foremost, is this a simple random sample? Well, we're going to have to presume that these 45 healthy males were randomly selected and therefore treat this as if it was a simple random sample. Then what we want to do is verify that the distribution of x bar is going to be at least approximately normal. And so either we need a large sample size or we need the sample to have no outliers and come from a population that is normal. For this particular example, we have a sample size of 45, so we have a large sample size, and therefore we can conclude the distribution of x bar is approximately normal because of the central limit theorem. Next, we need to verify that we have our independence requirement satisfied. We have 45 healthy males. How many healthy males do you think exist out there on the planet? Millions, right? Millions of healthy males exist. So our 45 is certainly a small sample size relative to the size of the population. And therefore we have our independence requirement satisfied. So all of the model requirements are satisfied, so we can go ahead and proceed with our hypothesis test. So the first thing that we want to do is state what the null and alternative hypotheses are going to be. The null hypothesis, recall, is always a statement of no change, no difference, no effect, right? And so we would be saying basically there's no difference between the resting metabolic rate of healthy males in complete silence versus the resting metabolic rate of males listening to classical music. And so we basically be assuming that these folks listening to classical music have a resting metabolic rate of 5710. So we assume the mean is 5,710 kilojoules per day. And we're looking to gather evidence to show that the mean is different, right? And so that means we're looking to check to see if the mean is different from, meaning not equal to, 5,710 kilojoules per day. So this is essentially our step 1. Our step 2 is to identify the level of significance. Our level of significance here is alpha is 0.05, right? And so now we have a technology, step 3, we need to obtain our p-value. And so we use whatever technology we want to obtain the p-value. We're going to use StatCrunch. And so within StatCrunch, we're going to go to the Stat menu, select T statistics, one sample. And in this particular problem, we have summary data. We have the summary statistics, the sample mean, the sample standard deviation, and the sample size. You'd pick with data if you had raw data. Okay? Our sample mean was what? 5708.07. Somebody write this down for me. 5708.07 was our sample mean. Our sample standard deviation was 992.05. And then our sample size was 45. So 5708.07 sample standard deviation was 992.05,
2.05.
and our sample size was 45. Click next. We're doing a hypothesis test. The mean stated in the null hypothesis is what? 5710, and we did have a not equal to alternative. And now all I need to do is click calculate. And we get the p-value as part of the output, 0.9896, which is a humongous p-value. Humongous p-value. P-value is 0.9896. And you remember how we interpret this p-value. If we were to conduct this experiment 100 times, we would expect to get the results that we got are more extreme in about 99 of them if the statement in the null were true. So let me write that down. If we conducted this experiment 100 times, we would expect results as extreme or more extreme in about 99 of them, meaning of the 100, if the true population mean was 5710. In other words, if the statement in the null were true. And so certainly we didn't get results that are all that unusual based on our assumption, correct? And so based on this p-value, what would you say? What would your conclusion for the test be, in other words?
You would not reject at all.
Yeah, do not reject the statement in the null hypothesis. Do not reject the statement in the null hypothesis, because our p-value is large. If you want to go the traditional route, you would say the p-value is greater than the level of significance. So here is step 4. P-value greater than alpha, therefore do not reject H naught. Do not reject the statement in the null. And so now we just want to formulate our conclusion. So we're going to say something along the following lines. There is not sufficient evidence to suggest that the resting metabolic rate of healthy males listening to classical music is any different from the resting metabolic rate of healthy males in complete silence.